Hello everyone, this is Jeannie Kam from GuruMe. So for today's class, we will talk about functions. I know everyone would have learned this function chapter in GCSE or MYP, but here we are facing IB, and because math is no fun, I will introduce you with the metaphor. So we know how vending machine works, right? We put $1 in, and then we get the product out. Let's say Sprite. This is the simplest form of functions. You put x in order to have y value. If the Sprite has many sizes, so there is a small size Sprite and large size Sprite, it may have different price, let's say $1 or $2. So even we put two different x values, we can have the same y. However, if we put, let's say, the two same price, $1 and $2, we can't have, we can have the same product of Sprite. However, if we have one same value, we can't have two different product, let's say Sprite and Coke, because our money is limited. It's just the same. We will talk about domain and range from now on and their relationship. So before we really dive into study of function and domain and range, let's talk about the relation first. So relations and functions. We all been into the car park and we know how charge becomes different depending on the time. This is the simplest form of the table, the price table. And we see total charge is dependent on the length of time, t. Because with this table, we can't be entirely sure how much we have to pay for an hour of the fee. Either it would be $5 or $9. We have to be more specific. So we rather, to avoid confusion, we can adjust the table into showing the relations more clearly, or we can also show the graph like this. So you can see, so this is the graph that you might not have seen well. The empty circle is exclusion mark and the filled in circle is inclusion mark. So it means when you only park from 0 to 1 hour, you will pay $5. 1 to 2, you'll pay $9. 3 to 6, you'll pay $13. So it's not really hard to read this graph. And the characteristics of this table and this graph is they are both showing a relation. So a relation may consist this from the domain to range, or we can have unordered pairs such as 1 to 5, -2 to 3, 4 to 3, 1 to 6. This parking example has the real value of interval of 0 to 24 hours is represented. And if we draw this example to explain domain and range, the domain of the car park is from 0 to 24 hours, while the domain of this relation is, so we know how coordinate works, x to y. So domain of x is 1, -2, 4, and 1 is repeating, so we can omit that in order to show it. So we put the domain in a middle bracket, so like this. And to represent range, for the range, the car park relation has the range of this charge. So $5, $9, $11, $13, $18, $12, $22, $28. And if we draw this example, it would be 5, 3, 6. And because this 3 is repeating, we can omit that. So now we will look further for relations and functions. So relation. Relation is any set of points which connect two variables like x or y or price to the product. A relation in math is often expressed in the form of equation connecting variables of x and y. In this case, the relation is a set of points x, y in the Cartesian plane or Cartesian grid. So if you draw, we know how to draw x and y, x on the horizontal line and y on the vertical line. And we count first from the right top and we go anti-clockwise, 2, 3, 4. So what we know from here is the first quadrant will have both positive pairs, positive x and positive y, while the second pair will have negative x and positive y, while third one in the opposite of the first quadrant will have both negatives, and fourth one in the opposite of second quadrant it will have positive to negative. So why is it really important in the functions? Why this Cartesian plane suddenly come up? Well, there's a story behind. So Cartesian is from René Descartes. He's really famous philosopher in he's an Englishman in England. Well, he was sick and he was lied down the bed in the hospital and he looked up the ceiling and then there was a fly is flying, and then a nurse came in and he asked the nurse to catch the fly for him. However, the nurse couldn't find him. So instead of saying the right top of the ceiling or left bottom of the ceiling, he rather said, well, if you make a x-axis and y-axis, you can see the first quadrant there. There is a fly. And let's say 3, 5, there was a fly. So nurse coded, and that's why he found Cartesian plane. Anyway, good stories, and we know the linear function and the quadratic function, and that can be expressed in the Cartesian grid. For example, the linear function as y equals x plus 3 shows it is going from the negative 3, 0 to positive 3, positive 0, 3. And for this function, although this function looks unfamiliar, it's actually inverse of what we know, y is equal to x squared, which looks like this. And then if you make this inverse function and then make a symmetry of it, you will have x equal y squared. Well, let's talk about x equal y squared a bit later and then focus on the functions. So, before we go into that, there are many ways to represent relation. For example, the first one would be by shading. The set of all points in the first quadrant is in relation of positive and positive value, and this is an infinite set of ordered pairs. So what it means by infinite set is there are infinite pairs exist, and ordered pair is, well, if we pinpoint one coordinate in any x and y plane, it would have a certain number, let's say 3, 5. However, the second way of representing a relation is just plotting down the coordinates on the Cartesian grid. So 13 points in the relation, and there is a finite set of ordered pair. So we can see there are 13, so that's why it becomes a finite function. So functions. Function is sometimes called mapping because we map the functions on the Cartesian grid, Cartesian plane. It is a relation in which no two different ordered pairs have the same x coordinate or first component. So we see from the above definition that a function is a special type of relation. How it becomes a special type? Let's dig in. Well, every function is relation, but not every relation is a function. So if we use a Venn diagram to represent this, it'll be relation and function. So what distinguishes function to relation? In order to figure out whether an equation is a function or not, we have to go for testing. So the first test that can be used is algebraic testing, and second one would be geometric test, or also known as vertical line test. So how about algebraic test? If a relation is given as an equation and the substitution of any value of x results in 1 and only 1 of y, the relation is function. So we already know the definition from the vending machine metaphor that if we put, let's say, $1 or $3, we can have a Sprite. However, with just $1, we can't have Sprite and Coke. So it's just the same. We can have, with many x value, x1 and x2, we can have the same y. However, with just the same value, we can't have y1 and y2. So y is equal to 3x minus 1 is a function, as for any value of x, there is only one corresponding value of y. So let's check from the previous page. So with any value of x, you will have 1y. Any value of x, you will have 1y. However, if x is equal to y to the power of 2, it becomes not a function, because when x is equal to 4, y will have either positive 2 or negative 2. There is more than one value of y of the given value of x. So it's like you have the 4 here, and then positive 2 and negative 2 for the products, which doesn't make sense. Let's check the graph again. So with one x value, you will have either positives or negatives. Positives or negatives, which doesn't really make sense. So that is the algebraic test. And in order to figure out more straightforward with drawing a graph, there is geometric test or vertical line test. If we draw all possible vertical lines on a graph of relation, the relation is a function if each line cuts the graph no more than once. So vice versa, if the line crosses more than 2 or more than 1, then it would be not a function. So let's check with the example above. If we draw any line, it's not touching more than 2 points, right? However, on the right-hand side, if we draw any line, it's touching 2 points at once. So we can say the right-hand equation fails to achieve vertical line test. So that's why it is not a function. So let's solve the example. Example 1. Which of the following relation are functions? So either we have to check whether 1x would correspond with 1y. That is algebraic test. So it seems like the a is passing, right? So we can say this is a function because algebraically 1x is corresponding to 1y. Let's look at B and let's try it with geometric test this time, or vertical line test. So we draw a vertical line. So far it's not meeting any of the graph. And now it's meeting at one point, meeting at 1 point, 1 point, and so on and so forth. So now it passes the vertical line test. So that's why it becomes a function. So yes, it's a function because geometrically it passed a vertical line test. However, if we look at C, before we choose to do vertical line test, we see 2 points are crossing one vertical line. So it is not a function because it can't pass vertical line test. Or we can use the algebraic definition, algebraic testing. With 1x, you will have 2 y's, which is not possible. Okay, so let's check the answer. It's a function, and not a function. So that is the gist of relationship. And before we dive into drawing a Cartesian grid, we will talk about graphical notes. If a graph contains a small open circle, such as this point is not included, while if it is a filled-in circle, it would be included. If the arrow contains an arrowhead at the end, such as this, then the graph continues indefinitely in that general direction, or the shape may repeat as it has done previously. So if we refer the first graph, it would be not including, including, and drawing graphs. And if we refer our previous example of this graph, this arrow would go indefinitely to the end. So that was the gist of functions, and we'll talk about more in our class. Thank you.